Hi there, folks. Today we're looking at solving by factoring. And solving by factoring comes down to one simple property. It's the zero factor property, all right? And so the zero factor property says this. It says if I have two things being multiplied, in this scenario it's A times B, and it equals zero, then one of those things has to be zero, all right? And really, that should make sense to us because we know that when we multiply by zero, it gives us zero. So in other words, if I have two things being multiplied and it equals zero, well then yeah, one of those things should equal zero. In other words, right here, either A is a zero, which means I have 0 times B, which is 0, or B is a 0, so then I have A times 0, which is 0, all right? When I multiply, in order to get 0, one of the things has to be 0. That's all the zero factor property says. But now all we're going to do is we're going to expand that to a more complicated example. Instead of having just a simple this times this, it's going to be a more complicated this times a more complicated that, all right? For example, if I look at something like this guy, this is the zero factor property at work here. When we look at this thing, I have two things being multiplied and it equals 0. The first thing is an x minus 2, and then it's times an x plus 4. All right, it's still two things being multiplied, albeit something slightly more complicated for each of those pieces being multiplied. But it's still two things being multiplied. Here's the first thing is the x minus 2. The second thing is the x plus 4. When I multiply them, it gives me 0, which means one of those things has to equal 0. Either the x minus 2 has to equal a 0, or the x plus 4 has to equal a 0. And now from here, I just have two really simple equations to solve. So this one, I subtract the 2 from each side, and I get x equals a 2. This one, I subtract the 4 from each side, and I get x equals a negative 4. And so what ends up happening here is I get two solutions. I have x equals 2 and x equals a negative 4. And that's it. And you can plug each of those back in. If you plug the 2 in, it gives you 0 in that first parentheses and a 6 in the second parentheses. It's giving us 0 times something. 0 times 6 is a 0. If I plug the negative 4 in, it gives me a 0 in the second set of the parentheses and a negative 6 in the first set of the parentheses. But then again, it's still something times 0, which gives me 0. So there are two different values that make this work, that give me 0 for each of those things, which gives me 0 for the product. Okay? This one, same kind of thing. I have two things being multiplied. The first thing is a 2x minus 1, and the second thing is an x minus 6. So all the zero factor property says is one of those things has to equal 0, so I do the 2x minus 1 equals 0, do the x minus 6 equals 0, and now I solve each of these. Here, I'll just add that 1 to each side, and then I divide by the 2. So again, we're solving a really simple example when it's all said and done. X equals 1/2. Over here, I have to add the 6 to each side, and I get x equals a 6. So I get two answers, x equals 6 and x equals a 1/2, and that's it. Okay? If I look at the next one, again, I have two things being multiplied and equals 0, which means either the first thing equals 0, so the 2x equals 0, or the second thing equals 0, the x minus 2 equals 0. And I just solve each of these. This first one, I divide each side by the 2. So that's x equals 0. The second one, I add the 2. And again, because I'm setting each piece equal to 0, I'm saying, hey, how do I get 0 for the first piece? How do I get 0 for the second piece? Basically, the x equals 0 gives me 0 for the first thing. And the x equals 2 gives me 0 for the second thing instead. But if either one of those things is 0, the whole thing multiplies to 0. This is why this works, okay? This guy, same kind of thing. The first thing is an x plus 3. The second thing is an x minus 3. So I set each of those equal to 0, and I solve. Here I subtract the 3 from each side, and I get x equals a negative 3. Here I add the 3, and I get x equals 3. That's it, done and done. Those are my two answers. Okay, the zero factor property says, hey, if two things are being multiplied and it gives you 0, one of those things has to be 0. But then I run into this guy and I go, okay, zero factor property, two things being multiplied, but wait a minute, this is not two things being multiplied. Okay, when you think about things that are being multiplied, when we see things that are being multiplied, we call those factors. And this is why it's called the zero factor property. It requires two things. It requires that the equation be set equal to 0, And it requires that the things be factored, all right? Because factors are things that are being multiplied. So when we look at this one, it's equal to 0, but it's not factored, so I have to factor it first, okay? So when I see a trinomial, I factor it by building a bridge. Two numbers that multiply to a negative 12 but add to a positive 4, or a positive 6 and a negative 2. I get to use my shortcut on this one because there's a 1 out front. That's a 1x squared. So I can go right to the two factors of an x plus 6 times an x minus 2. And now I'm in a situation where I have two things being multiplied equals 0. So now I say, hey, if these two things being multiplied equals 0, either the first thing equals 0 or this second thing equals 0. And now I can solve each of those. So the first one, I'm going to subtract the 6 from each side. So I get x equals a negative 6. The next one, I'm going to add that 2 to each side. So I get x equals a 2. And that's it. It was one extra step of, hey, I have to put this thing in factored form so I can use the zero factor property. All right? And so again, look for those two things. Like when I see this one, zero factor property, it's equal to 0. I got that part down. But it's not factored, so I have to factor it. All right? Again, the zero factor property requires two things. It requires that I'm equal to 0, and it requires that I factor this thing. So two numbers that multiply to a positive 20 but add to a negative 9 are a negative 4 and a negative 5. And once again, there's a 1 out front, so I get to use my shortcut here. So I can go right to the x minus 4 and the x minus 5. And now I have the zero factor property set up where I have two things being multiplied equals 0. So I can use the zero factor property. Either the first thing equals 0, the x minus 4, or the second thing equals 0, the x minus 5. And now I solve each. Over here, I'm going to add the 5. Done and done. Okay? But again, the zero factor property, it's got to be set equal to 0, and I have to be in factored form, and then I just set each factor equal to 0. Okay? This is how we solve quadratics. If I look at this one, same kind of thing. Zero factor property. Is it equal to 0? Yes. Is it factored? No. So let's factor it. And please, when you see this thing, as soon as you see only two terms, we should be thinking, okay, greatest common factor and special cases like difference of squares. This one is just the greatest common factor. Remember, always look for the greatest common factor first. Here I could factor out a 2x, leaves me with an x plus 5. Now the thing is factored, so either the first thing equals 0, the 2x equals 0, or the second piece equals 0, the x plus 5 equals 0. So I set each factor equals 0, now I solve each. Here I divide by the 2, and I get x equals 0. Here I subtract the 5, and I get x equals negative 5. If I look at the next one, again, same thing. Greatest common factor. Here I can factor out a negative 3x. Leaves me with an x minus 7. And now I can set each factor equal to 0. So either the first factor, the negative 3x, equals a 0. Or the second factor, the x minus 7, equals a 0. And now I solve each. This one I divide by the negative 3. And if you haven't noticed yet, this whole thing, being able to do this, really hinges on your ability to factor. If you're not good at factoring or you don't remember how to factor, sorry, I should be adding a 7, then you got to go back and review factoring, okay? If you are really good at factoring, these problems are super, super, super easy, okay? Because all we have to do is factor it and set each factor equal to 0. If I look at this guy, again, it's equal to 0, so zero factor property, I've got it equal to 0. I just need to factor it, so here I build a bridge. Two numbers that multiply to a negative 8 but add to a positive 2, or a positive 4 and a negative 2. I can use my shortcut on this one because, once again, I've got a 1 out front here. So this thing's going to factor into an x plus 4 and an x minus 2. And now I have two things being multiplied and an equal 0, so one of those things has to equal 0. Either the x plus 4 equals a 0, or the x minus 2 equals a 0. And now I solve each. Here I subtract the 4, and I get x equals a negative 4. Here I add the 2, and I end up with x equals a 2. That's it. If I look at the next one, zero factor property, I need it equal to 0, and I need it to be factored. Well, this one's not even equal to 0, so I have to get it equal to 0 first. And the easiest way to do that in this one would be to add the x squared to each side. Now, maybe you're looking at it thinking, well, maybe I want to add the 9x and subtract the 20. You could do that as well. But I like adding the x squared because I want a positive value for my x squared anyway. The second piece of this thing is to make sure you write it in the proper order here. When you look at this guy, I want to write the x squared first, then the minus 9x, and then the plus 20 equals 0. And I could have all that on the other side. It doesn't matter. I switched sides. Okay, that's fine. But make sure you write it in descending order. Remember, descending order is important because that's the format we need it to be in before we start building a bridge and factoring. So now I can work my way towards factoring. So I build a bridge. Two numbers that multiply to a 20 but add to a negative 9 are negative 4 and a negative 5. And once again, I get to use my shortcut because there's a 1 out front. So this factors into an x minus 4 and an x minus 5. And now I have the situation where two things being multiplied and equals 0. So one of those things has to be 0. Either the x minus 4 equals a 0, or the x minus 5 equals a 0. And now I solve each. So here I add the 4 to each side. This one I add the 5 to each side. So x equals a 5. Whew. Piece of cake. If I look at the next one, again, it's set equal to 0, so I'm almost there. I just need this thing to be in factored form, so I build a bridge. This time I build a bridge and I get a negative 12. Two numbers that multiply to a negative 12 but add to a negative 1 are a negative 4 and a positive 3. But this time I can't use my shortcut. I've got a 2 out front. I can't use the shortcut when there's a 2. So remember, I split up the middle term and I factor by grouping. I rewrite this as 2x squared. And then that negative x in the middle I write as a minus 4x and a plus 3x. A negative 4 and a positive 3 still gives me that negative 1 in the middle. All right. But I'm splitting it up and writing it as 4 terms now so that essentially I can do factor by grouping. All right. So out of the first group, I can factor out a 2x, which leaves me with an x minus 2. Out of the second group, I can factor out a 3, which leaves me with an x minus 2. And now I can see the common polynomial between the two is the x minus 2. If I were to take that away, the two factors are going to be a 2x plus 3. That is a terrible looking parenthesis over here. I can't live with that. And an x minus 2. And now I'm set up for the zero factor property. Two things being multiplied equals 0. Either the first thing equals 0, so either the 2x plus 3 equals 0, or the second thing, the x minus 2, equals 0. And now I can solve each of these. Okay, so this first one, I'm going to subtract that 3 from each side. And then divide by the 2. And you know, some of these are easy enough to solve that you could do some of it in your head, but just be careful, especially with some of the signers that students make. So here I add the 2 to each side. Yeah, see, this is one you could probably solve in your head and go, oh yeah, x equals 2, without actually showing that work. All right. But that's it. Get it equal to 0, factor it, set each factor equal to 0. If I look at the next one, again, it's not equal to 0. I have to get it equal to 0, so I'm going to subtract that 12 from each side first. And so this one, I end up with a 3x squared plus 9x minus 12 equals 0. And just make sure you put it in descending order like that. I want it in that format before I factor. And now here, most of you are probably tempted to go ahead and build a bridge, but I'm not going to do that yet, because if you look, there's a greatest common factor of 3 between all of these. We should always look for the greatest common factor first. And normally, if I was just factoring, I would factor out the 3 and leave it on the outside. But because it's an equation, I can actually just divide each side by 3 and get rid of the constant term completely. Okay? And that's a little bit different than what we've done previously, because we didn't have an equation before. All right, now we have an equation. We're allowed to do the same thing to each side of the equation. Now it's equal to 0. I'm ready to go ahead and factor. I build a bridge. Two numbers that multiply to a -4 but add to a +3 are going to be a +4 and a -1. And now because I got rid of that greatest common factor first, I do have a 1 out front, and I get to use my shortcut. So this factors into the x plus 4 and the x minus 1. And the other thing that you should make note of is if you didn't see the greatest common factor here and you went ahead and built a bridge right out of the gate, that's okay. If you split up the middle term and factor by grouping, you will get two factors that will still give you the same two answers that we're about to get. You won't have what I have here and have an x plus 4 equals 0 or an x minus 1 equals 0, but you will have factors that will give you the same answer when you solve this thing, okay? And so here I subtract the 4 from each side. Over here I'm going to add the 1 to each side. Oh, and I ran out of space, so let me write my answers up here. So x equals a -4 and x equals a +1. Okay? But again, if you don't see the greatest common factor, that's okay now. You're going to build a bridge. You're going to split up the middle term. You're going to factor by grouping, and you are going to get the same answers, even though your factors will look a little bit different than mine. Okay? If I look at this next one, it's got a fraction in it, okay? So a couple things here. One, it's not set equal to 0. It's not factored, so I'm not ready for, the 0 factor property. So here, maybe I would subtract the 8 from each side. Great idea. And then after I do that, again, write it in descending order. I could build a bridge here and do the 1/2 times the -8. But man, I really wish that 1/2 wasn't there, right? And if there's one thing that I've said a lot this year, it's that whenever you're solving an equation, you can always eliminate fractions by multiplying through by the common denominator. So here the common denominator is a 2, so watch this. Let me just go ahead and multiply each side by 2. Say, you know what, I'm not dealing with fractions. Mr. Jansen told me I can always get rid of fractions by multiplying through by the common denominator. So here, if I distribute that 2, that gives me an x squared plus 6x minus 16 equals 0. And doesn't that look a lot easier? See, now I can build a bridge. Two numbers that multiply to a -16 but add to a +6 are going to be a +8 and a -2. I get to use my shortcut on this one because there's a 1 out front now. So x plus 8 and an x minus 2. Now I'm set up for my 0 factor property. Either the first thing equals 0 or the second thing equals 0. And now I can solve each of these. The first one, I'm going to subtract the 8 from each side. The next one, I'm going to add the 2 to each side. And once again, I kind of ran out of space here. Let me write it up here. Sorry, blue. So x equals a -8 and x equals a +2. But that's it. All right? We still have all the same tricks up our sleeve that we've had before we got to this lesson. And then the last one, nice easy one at the end. If you recognize this thing as what it is, it's an x squared minus a 25. So a perfect square minus a perfect square, that is a difference of squares. And a difference of squares factors into conjugates. So this factors into an x plus 5 and an x minus 5. And again, if you don't remember difference of squares, you got to put a 0x in the middle and then build your bridge, okay? But now I can set each factor equal to 0. And I solve each. And it's really important that you understand that there's two answers for this particular example. Some students will try... Sorry, I'm getting a little funky with my colors here. My computer's going a little slow right now. I've worked it too hard. But some students will try to kind of add that 25 over the other side, and then they start thinking about, oh, something squared equals 25. Oh, it's got to be a 5. But they always miss the -5. So please do it by factoring to make sure you get that +5 and the -5. Okay?